Hello, good morning, good afternoon, good evening, everyone, and welcome to this episode of our Ask Me Anything webinar series, which is called Wi-Fi 7, MLO, and Real World Experiences. So we're thrilled to have you all here, whether you're joining us from across the street or from halfway around the world. We're in for another thrilling session as we dive into some more interesting information from the wireless technology space. So again, today we are lucky to have our presenter who is both an expert and a visionary in the field. And Phil Morgan has spent over 2 decades helping to shape the future of wireless technology, working with organizations worldwide, helping to implement cutting edge solutions that drive efficiency and growth. From wireless technology to cybersecurity, Phil has a deep understanding of the technologies that are transforming industries and is here to share some of his valuable insights with us. So as I mentioned, during today's session, we'll be exploring MLO. So be ready to take notes and ask plenty of questions at the end in the Q&A segment. So without further ado, please join me in welcoming Phil Morgan, who will be taking us through today's discussion. Phil, it's over to you.
Thank you, Ree. That was a great introduction. So without any further ado, let's do this. I just want to mention and point out that everything we're talking about here is brand new. Technically, they have finished the projects now, and Wi-Fi 7 and BE are ratified. BE is not yet published. It's still going through final phase editing. And this is a good point to mention that BE and Wi-Fi 7 are not the same. And it's very important, anybody on the session today and anybody watching this, they are not the same. Wi-Fi 7 was released in release 1 over a year ago in January 24. BE is just about now coming to fruition. And so it's probably fair to say that everything in Wi-Fi 7, which is a Wi-Fi Alliance certification, comes from BE. But don't think for a second that everything in BE is in Wi-Fi 7. Okay. The Wi-Fi Alliance are working on release 2, which is expected to come out, last I heard was a year or two. So it could still be a little while off. And one key thing to remember about the standards process is not everything that's in the protocol will end up being in the clients and in the APs. Okay. So there are things that are mandatory for APs and clients to support, but there are other things that are optional. Okay. Just want to mention here that we have tried to make it as up to date as possible, but it is subject to change. I'm going to zip through these. If anybody's really interested, you can rewatch the video on YouTube. So I'm not going to spend too long going through and telling you about me and about NCX, but I think Ree did a great job of doing that anyway. And so there's my contact details. You are more than welcome to add me on LinkedIn, Twitter, and my email address is there as well. And some of the blogs that I'm involved in. So why are we here? This is our AMA session. Ree and I saw a lot of questions being asked in the Slack channel, or the Wireless LAN Professionals Slack channel. And we thought, why don't we just start talking about things that people are asking questions? And so the first one we did was about Wireshark. And why does Wireshark say that the frame size is something that it's not? And we talked about, do packets lie? There's a saying going around that packets never lie. Well, is that true? And we proved that it is true. The packets never lie. But our interpretation and our understanding through tools like Wireshark may lead us down the wrong path. So we need to make sure what we were doing. Well, this second session is all about MLO. So I can see you all sat there going, come on, Phil, get on with it. So let's just do this. So today's schedule is going to be, we're going to talk about an introduction to Wi-Fi 7 very briefly. Then we're going to talk about MLO. Then we're going to talk a little bit about how we can look at this information inside Wireshark frames. So a quick intro to Wi-Fi 7 for anybody that's been living under a rock for the last year and doesn't know what Wi-Fi 7 is. The Wi-Fi 7 is released by the Wi-Fi Alliance as a more user-friendly reference to the technologies. It started off with Wi-Fi 4, which you may know as 802.11n. Wi-Fi 5 was AC, 6 is AX, and 7 is BE. And we are working on Wi-Fi 8, by the way. Now that Wi-Fi 7 is nearly here, now we can start talking about Wi-Fi 8, which is coming. We are not expecting Wi-Fi 8 until much later in like maybe 2028. So it's a good 4 years away expected at the moment. So I'll let you have a little look at this. Really what we're excited about are the speeds, channel bonding, and MLO. And of course, a lot of these aren't real. We don't recommend you start using 320 megahertz channels, especially if you're in Europe. You're just going to eat up the entire 6 gigahertz. And will we get 46 gigabits? We'll see. Who cares about this? Well, gaming is one group that has been mentioned a lot, and they aren't necessarily talking about you playing a sniper game online. Gaming actually has entertainment, sports, and esports. So, soccer games, football games, baseball, other types of sports. Being able to view from multiple viewpoints the goal or the try or whatever it was, or the touchdown, that's very interesting. And from sponsors and marketing companies, they want to be able to give the user a better experience than just watching this screen in the corner of the room. It has practical applications for healthcare, emergency services, IoT, HD streaming. Okay. The concept of watching more and more higher definition videos or television content requires faster and better bandwidth. If you are playing a golf simulation or a shoot-up game like Doom or something, there's a lot of problems with your headset and synchronization to your movements. That really needs to be finely tuned to stop people feeling nauseous. So augmented reality, virtual reality that come under the banner of XR are very practical applications. And so it's not just a faster experience, it's a better experience. It's very important we understand that. And so, yes, we will have higher throughput, but deterministic latency, increased efficiency, greater reliability, this is very important as well. Okay. One of the problems we suffer from at the moment, even with Wi-Fi 6, is if you are on a voice call, voice over IP, voice over wireless, and somebody in the house is streaming music or listening to a TED talk, they may both be regarded as voice. Well, your voice meeting is more important than the TED talk. If you're on a Zoom meeting and someone's watching Netflix, the Zoom meeting is more important than Netflix, but they are both regarded as video content. So one thing that Wi-Fi 7 aims to bring around is a separation of true real-time data and non-real-time data. Because non-real-time data, like a video stream, can buffer. And so you don't experience loss. Even if you do have a system loss or a connection loss, the buffer will keep you going while the system reconnects you. That is not true if you're on a Zoom call. So here's a quick overview. Most clients today are two spatial streams. And so in reality, the fastest you can go isn't 46 gigabits with two spatial streams. It's really 5.7 gigabits. If you do have four spatial streams, like in an AP or a desktop computer, I say desktop because most laptops and mobile devices are two spatial streams. You can buy more spatial stream devices, but they tend to be on like a PCI card that fits inside your desktop computer, not a mobile device. It needs to be a full powered, constantly powered device to use this functionality. One application we are seeing for four spatial streams is in mesh, and that's still being worked on and tweaked, where APs could use Wi-Fi 7 at four spatial streams to create backhaul mesh links. Again, that's something that is coming out now. So for two spatial streams, 5.7 gig. For four spatial streams, typically double that, which is 11.45-ish. And so there's a summary of what we're talking about. The majority of clients we're expecting now is going to stick with two spatial streams. And there was a great talk at WLPC, which I just came back from yesterday, where Wes from Juniper did a talk on the difference between two spatial stream and four spatial stream APs. And if you have a four spatial stream AP, it actually can give you up to 3 to 6 decibels of better quality because of its use of beamforming and such things. And even though the clients are two spatial streams, don't think that you need to only buy two spatial stream APs. There are still benefits of still using four spatial stream APs. The limit was bragged about being 16 spatial streams, but in reality, we think it's going to stay at 8 spatial streams for Wi-Fi 7 for now. 16 spatial streams is not included in Wi-Fi 7 and may be bumped to release 2 or maybe Wi-Fi 8. And again, don't think you're going to end up with 16 spatial streams in your mobile phone or something. That's probably not going to happen. And so here's the channel bandwidth we have available in 6 gigahertz. If you do start running 320 megahertz, you will have 3 usable channels in 6 gigahertz, whereas in Europe, you just get 1. And here's an example of my Ubiquiti using 320 megahertz in 6 gigahertz. And there are actually 2 choices. There's the lower and the upper channels that you can use in the US. So in reality, if we don't use 320 megahertz, what if we use 160 megahertz? Well, it's just simple. Just half it, and you'll end up with approximately 2.8 gigabits. What if you use 80 megahertz, which is most typically expected in the US for 6 gigahertz? That may drop down to 40 megahertz in Europe because of the reduced space. You may only get 1.4 or less, which isn't that much faster than what you can get with Wi-Fi 6 AX, but it is faster. So here's a nice picture of my S24 connecting at 5.7 gigabits to a Wi-Fi 7 AP. Fantastic, right? And then I actually did some iPerf testing just to see what I could get. And there was no protection used or making sure the neighbors weren't doing anything. This was me just bringing up iPerf on my MacBook Pro with a 10 gigabit per second port and connecting iPerf on my Samsung and connecting the two together and just doing some speed testing. So again, this wasn't in like a chamber cutting out the neighbors or anything. This wasn't official testing. It was just let's see how fast we can go. And we repeated this at the Wi-Fi 7 Fest at WLPC that just finished. And we were seeing people that were reporting 3 gigabits per second with Ruckus and Ubiquiti. Again, 10 gigabits per second, Ethernet at the back end. And we were seeing above 3 gigabits actual speed tests and iPerf tests. So here's an example of what I did, some testing, and I showed that you can get up to 700 megabits in iPerf on a 1.4 gigabits connection with two spatial streams. And it actually seems to be a little bit more efficient as you go down to the 80 megahertz. Okay. I didn't actually try a single spatial stream because I haven't got a device that does that. So that would assume to be approximately half of the 0.7 megabits that you'd get in that situation. And again, I was standing 4 feet away from the AP. 4K QAM needs a huge signal to noise ratio. And this is all done on low power indoors. Again, we are not going to start using 320 megahertz. We should really maybe keep it on at 80 megahertz in 6 gigahertz. And I'm going to speed up a little bit because I'm talking too much about Wi-Fi 7 and I want to get onto MLO. And so MLO then. So MLO is quite simply having multiple links between a client and an AP and aggregating or selecting the use of those links. Okay. Might be worthwhile just quickly mentioning what is a station, an STA it's called. Now, technically a station is anything that has a Wi-Fi radio. So our AP stations, yes. Our client stations, yes. But the industry as a whole tends to refer to an AP and a stay or a station, and they mean client. So the station will connect to the client. Okay, it's used throughout the entire industry, and even in some of the material that's written by the bloggers in the industry as a whole. But technically, a station is anything that has a radio. Why do I mention this? This is going to become very important in Wi-Fi 7. Wi-Fi 7 now has the concept of a multi-link device. And that's just simply a device with multiple links. That's simple. An AP or a station with multiple wireless interfaces. Now we also have the concept of an AP and a non-AP multi-link device. That's the client, all right? The thing to understand is the links between the AP and the non-AP multi-link device each use the terminology of a station today. So we have to stop thinking about the station as being the client. One of the things that shocks most people with MLO is MAC addresses. If you start looking for MAC addresses in Wireshark, you might not see them because multiple links require multiple MAC addresses. So a quick review of the OSI 7-layer model. Okay, I'm going to speed through this because what we care about are the TCP/IP layers. Sometimes they say there's 4 or 5. If you break out the network access layer at the bottom to data link and physical, which we tend to do because Wi-Fi and Ethernet is all about the lower 1 and 2 layers. And so in Wi-Fi, we break the data link layer into the LLC and the MAC layer, the upper and the lower, and we break the physical layer into the PLCP and the PHY. Okay, physical layer convergence protocol and the physical amendment and frequency that you're working with. So there's an upper and a lower in the physical layer as well. In the data link layer, we refer to frames. At the internet layer, we have IP packets, and then at the physical layer, we have bits. So if IP addresses at layer 3, MAC addresses at layer 2, and then bits at layer 1. Nice and simple. Well, everybody knows, if they've done a CWNA or a CWAP class, at layer 3, you have an IP packet. That has an IP header, and it has a payload that is the TCP or the UDP, which in turn has a payload of the application data. When this data arrives at the LLC layer, it is technically becomes an LS, linked layer data unit, But don't get hung up on that. Soon as that arrives down at the MAC layer, it becomes an MSDU. And that's the name you're more likely going to see it as. And an MSDU is simply 8 bytes added to the front of an IP packet. They're not always the same 8 bytes, but they generally are. If you use IP version 4 and IP version 6 and other things, they're going to change. But generally, it's a mapping of 8 bytes that represents the information from the upper layer of layer 2. You can just think of this as an IP packet with 8 bytes added to the front, and that's all you need to care about. Now that becomes the payload of the wireless frame, and the wireless frame is the MPDU. Again, when that comes down to layer 1, the name changes to a PSDU, nothing else. If I go to the post office, I say to the lady, could you send my parcel to England? And she goes, oh, you want me to ship your box? I'm like, parcel. And she says, box. We can stand there and argue, or we can just agree that we have different names for it. So the MPDU is the wireless frame. That becomes the payload of a physical transmission that is the PPDU. Now, why am I going on about this? It's very important you need to understand. The MLD requires that we now need an extra split at the MAC layer. And just to mention, Wi-Fi 8 is promising MLO to different APs. At the moment, it's only MLO to the same AP. So multiple links on a single AP. And watch out for this. Each of those links can be referred to as an AP. And so we actually split the MAC layer now into an upper and a lower entity. Now, let's assume that you have a Samsung S24 connected to a Cisco AP using MLO. Each of them will have a MAC address at the upper MAC layer, the MLD address, and each of them will have a MAC address at the link layer. And it gets more confusing because it's possible that a device may choose to use one of the physical interface lower MAC addresses as the MLD address. So a Samsung S24 with a Cisco AP, each end will have 3 MAC addresses, but they may have 2 if they reuse one of the lower MAC addresses. So you won't always see 3. It's vendor specific. You may see 2, but there will be 3 MAC addresses in use, but one of them just may be used for the MLD and for a actual link. And so we talk about the concept of a link. Now, there are specifics. I'm not going to go through this. We don't have time for this. But there are specific functions that are done at a specific layer. So authentication is done at the upper MAC layer. And so what will happen is between a client and an AP, they may have 2 links that they support. They do not have to have an individual PMK for each of those links. So the PMK is done, the security association and the security attributes, the PMK, is done at the MLD level, which makes life a lot simpler. However, there is a caveat. What if a Wi-Fi 5 or a Wi-Fi 6 device connects to your AP? So the AP has to still maintain a non-Wi-Fi 7 functionality. And now we have a problem. Okay? When we use broadcast and multicast frames, so the PMK applies to the upper MAC, but each of the lower MACs will have their own broadcast key. So watch out for that. That's a CWAP exam question, if ever I've seen one, right? Okay? So be aware that because of backwards compatibility functionality, that the broadcast key is used differently at the lower MAC layer. And so MLO is real simple. It's multi-links. Okay? SLO is normal operation like we know now with some tweaks. MLO is the ability to use multiple links. So if you have MLO SDR, that's 2 independent radios. If you have MLO NSDR, That is two physical radios, but they have to be used as a pair. They cannot independently operate. So the simplest form of MLO is MLSR. And I'll give you a heads up now. How do you understand what's going on? Look at the last two letters. If it's SR, it's a single radio. If it's MR, it's more than a single radio, multiple radios. So MLSR has to be supported by all clients. It's the same as Operation Now with one major difference. The client can authenticate on multiple actual links. Today, if I want to move my connection pre-Wi-Fi 7 from the 2.4 to the 5 or the 5 to the 6 gigahertz BSS on my AP, that is actually a roaming event. Roaming takes place. With MLO, that is no longer a roaming event. I can just simply flip to the new frequency and use it. It does not require any roaming activity from the perspective of the AP and the client. Very, very powerful. So MLSR, you can authenticate on 1, 2, or 3 links, and you can flick between them as you want to. Flick or flip between them as you want to. So that roaming thing is very important. Now, just putting this out there, could this speed up roaming in Wi-Fi 8 if we have inter-AP MLO? Don't know, just mention it. There is another mode called enhanced multi-link single radio, and that's where you've still got a single radio, but the single radio is built with I'm going to use the word a big radio and a little radio. There's a little radio functionality built into the chip. So you have the normal big radio that does all the normal transmissions. But what can happen is the device can listen on 2 different channels. So it can take its 2x2 spatial stream functionality and put one stream on one channel and one on a second channel. It can also, whilst transmitting or receiving on one channel, it can do initial control frame exchanges on the other channel, and it can also do CCA, clear channel assessment, on the second channel. But typically what happens when it chooses to transmit or receive, it will select one channel and then go into a 2x2 mode. But it does have the functionality to start a conversation or listen to a conversation on one channel and listen to another channel at the same time. So 2.4 and 5 or 5 and 6 or something. So this is enhanced MLSR. It's MLSR with a little bit of extra cream on top. That's cream and strawberries on the cake as well as the icing. And then you have typical ML, MR. And STR is multi-link, multi-radio, simultaneous transmit and receive. And that's exactly what it says in the name. It can transmit and receive on 2 channels or 2 frequencies, and it can transmit on one frequency and receive on another. And just to mention, by the way, there is no explicit rules in the specification that says that your 2 links have to be on different frequencies. So you could use 2 links on 5 gigahertz and 2 links on 6 gigahertz, maybe, theoretically. We aren't seeing this that I'm aware of now, but theoretically it's possible. The problem comes, however, if you're using like the high end of 5 gigahertz and the low end of 6 gigahertz, when you got an AP or a client transmitting and receiving, if the channels are too close together, they're going to interfere with each other. And so MLMR has to be carefully coordinated. The channels do not overlap. Each link can independently do its own thing. There are 2 additional multi-radio modes. The first one is non-simultaneous transmit and receive, where transmission and reception has to be synchronized between the transmitter and the receiver. Maybe the channels are too close together and they will interfere with each other. Again, this is very, very complex. There's another mode as well called Enhanced Multi-Link Multi-Radio, STR. This is MLMR STR with dynamic spatial multiplexing on each link, similar to the enhanced concept with EM LSR. However, neither of these are in the Wi-Fi 7 Release 1 certification. And so they're not expected to become that popular. So MLO is mandatory. An AP must do MLMR STR. The client must do one type of MLO. It may just do MLSR or EM-LSR. Although APs have to do MLMR STR, there are some low-end APs that may not do it as an option. So I can't say every AP will do it. Every AP that wants Wi-Fi 7 certification needs to do MLMR STR. So pay attention to the last two letters, MR, multi-radio, SR, single radio. So just a quick discussion on the clients. In August, I wrote this slide, Samsung S24 and the Google Pixel 8. They were MLMR STR. Okay. The Intel BE says it's EM LSR. And the Qualcomm 7800 reference adapter says that it's MLMR STR. And the Samsung S24 and the Google Pixel 8 will do 2.4 plus one other. The 7800 states it will do 5 and 6 functionality. 6 months later, in February, I wrote this slide. The iPhone 16 has come out. Now, the last I heard, a rumor, was that it's MLMR STR if you do 2.4 and 5 link MLO. But if you go to 5 and 6, it becomes EM LSR. And I don't know enough about the Google Pixel, so I'd love for you guys to write a blog or do some more talking about it. And this isn't about me or NC Expert doing this. This is about me and NC Expert starting off talking about Wi-Fi 7. And I'm hoping you guys and gals will write more blogs and go on. And if you have a Google Pixel 9, let us know, let the community know what's going on with these devices. And this is all going to change, guys and gals, all right? This is going to become more and more functional and operational as the vendors move forward with their firmware updates and algorithms and so on. Our friends at Alethea have done an actual real world testing on MLO and interference and delay functionality. It's very, very worth watching. It's a contrived delay because they had to have equality in the environment. So it's not real world testing, but it's the closest thing we've got at the moment. And it's very interesting. They do actually show that MLO does make a difference. Now, I don't want to put the cat amongst the pigeons, but we did a lot of Wi-Fi 7 testing at WLPC that I just came back from yesterday. And we had Ruckus, Ubiquiti, and Eero in the room supplying the hardware, and we had everything. We had Google Pixel 8s, 9s, iPhone 16s, Samsung S24, Samsung S25s, and more. And the one thing we found, we had much better speed and performance when we turned off MLO. Now, if you're listening or watching this video and it's the middle of 2026, you can laugh about how naive we were at the start of 2025. But contrary to what we all thought, hands-on practical operation, MLO, we could not get high speeds with MLO turned on. Literally, the vendors were saying to each other, dude, give it a try with MLO turned off. One vendor turned to another vendor and says, how are you guys going so fast? we got MLO turned off. Oh, and as soon as that vendor turned off MLO, they got almost a double of what they got with MLO turned on. Now, I'm not saying MLO is bad. I'm just saying that I think the vendors have some tweaking to do, both the client vendors and the AP vendors, to get the algorithms working smoothly. Interesting. And one other thing to mention, in reality today, what we're seeing with MLO is we're seeing 2.4 plus one other. Okay. We're not seeing much 5 and 6 MLO. And I, as a personal opinion, I'm not entirely excited about MLO connecting 2.4 gigahertz. If 2.4 operation is going to save your network, is going to come to the rescue on your network, maybe you've done it wrong, right? 2.4 isn't hardly ever the superhero in this scenario. But because SSIDs have to be the same with the same security settings on all channels that you want to MLO link, this could lead to interesting functionality. So vendors are showing improvements in their testing, but in our real world testing, where we just put some APs and get some clients, we're not seeing that much benefit yet. And again, if we can get 5 and 6 gigabits to work, that is going to be phenomenal, right? So remember we talked about 320 megahertz operation. If we bonded 5 and 6 gigahertz together, we have a theoretical combination that peaks out at 8.5 gigabits. But again, that's in a perfect world, theoretically, with 320 megahertz and 160 megahertz in 5 gigahertz. So not optimal for enterprise use, but a potential connection throughput. Okay. I just want to talk about some tools. If you have a Samsung, you can go into Samsung Intelligent Wi-Fi and use Connectivity Labs, and you can actually look at the link speeds, and you can clearly see the functionality that you are using with MLO. Fantastic tool that's inbuilt into the Samsung systems. You've got Wi-Fi Man from Ubiquiti that will also give you some functionality, and we had some good testing with Wi-Fi Man. And this is a shout out to one of my favorite tools, which is Analyty. You do have to upgrade, and it's not very expensive. You do have to upgrade to the full package to get MLO to work, but you can clearly see it showed that the reason that the screen is a bit wonky, as we call it in England, the screen looks a bit deformed, is because I blanked out the MAC addresses that was being used. And it's comical because I haven't done that in the Wireshark screenshot, so maybe I shouldn't have bothered, but I did. So I blanked out the MAC addresses, but you can see that there is a MLD MAC address, and then there are 0, 1, and 2 link addresses. Okay? So it's connected to 3 links, and it can simultaneously use 2. Interesting, right? And I just wanted to do a shout out that Microsoft, now you do have to have Microsoft 24H2, the latest drivers installed. And NetShell wireless LAN show drivers, show interfaces, will show you wireless functionality. And in my testing, this was a few months ago, I couldn't get my, I've got an Intel BE in a Dell laptop. I couldn't get to go more than 2.4 gig. But in the WLPC Wi-Fi Fest, we did get 3 and 4 gig functionality off Windows devices. There's also NetShell WLAN show wireless capabilities as well. Just a quick, very quick introduction because I want to get to Q&A. This is not going to make you an expert at Wireshark with Wi-Fi 7, but just to let you know what you're looking at. In Wi-Fi 7 in Wireshark, there is an extended tag now, There is EHT capabilities and EHT operation. And they will advertise the capabilities and the operation of the Wi-Fi 7 network. If you go and look in there, you may be disappointed because you will not see what you're expecting to see. All right? Now, I usually ask people a simple question. If it's a Wi-Fi 7 certified device, which Wi-Fi does it support? And everybody says 7. I said, yes, and they think about it for a minute and they go, oh, 654. A Wi-Fi 7 AP and client has to support Wi-Fi 6, Wi-Fi 5, Wi-Fi 4, A, G, and B protocols. All right? And to simplify and to reduce the overhead in beacons and probe frames, the Wi-Fi 7 developers will leverage Wi-Fi 6 and Wi-Fi 5 information. So, for example, if you put the Wi-Fi 7 AP on 320 megahertz mode, you'll see 320 megahertz in the capabilities in the operation. If you put it on 160 megahertz mode, you will not. Because Wi-Fi 7 is, no, go and look at the previous generations. We are building on top of them. So you still have to be aware of what the Wi-Fi 6 and in some cases the Wi-Fi 5 elements say, not just the Wi-Fi 7 elements. So just to mention, well, as soon as you turn on MLO, so if this is all you see, you're not using MLO. Okay? If you turn on MLO, you will see a new tag, a new element called the multi-link element. I'm just going to run through this very quickly to give you a heads up. So in beacons, so there is concept we have of the basic multi-link element. It's got a lot of attributes in it, a lot of information. So you'll see this in beacons. And first of all, it'll tell you, do we have the EML capabilities? That should be MLD capabilities. And yes, they are present. And there's the EML. So it shows you here, for example, this particular device supports EMLSR and it does not support EMLMR. And then you'll have, this is a very important attribute. Computers start counting at 0. So if it says that we support 2 simultaneous links, it means 3. You have to add 1 to that number if you want to see the real number of supported simultaneous links. We have something called a TID in Wi-Fi 7, which is a traffic identifier. Currently, it's used very similar to the UP attribute, but it does have future expandability. And one of the things you can do is you can map a traffic identifier to a link. So you can say, for example, all traffic goes over this link, but very important real-time voice or video goes over this second link. And you can keep the second link for that traffic only. You will see the MLD address appearing in the frames, the upper MAC. And then you'll see that the link ID is an identification of the link that is advertising this beacon. Now, very important, if you want to make a note of this, we're not going to go into it now. RNR, the Reduced Neighbor Report, and beacons, and RNRs in beacons become very, very important for Wi-Fi 6. The client isn't going to go and listen or maybe probe on every single frequency. So you may see that a client will try and authenticate and associate with an AP on 6 gigahertz because it saw in a 2.4 gigahertz beacon that AP advertised that it also has a BSS operating on 5 and 6 gigahertz. And one of the biggest things you won't see if you're looking for this, it can be very disappointing, The typical client connectivity before Wi-Fi 7 was maybe listen to beacons, but it's probe, authenticate, associate. The client does not do that on every single link frequency, every channel. The client can literally say on 6 gigahertz, hey AP, I want to probe and authenticate and associate to you on 6 and 5 and 2.4. So you may only see one set of probe, authenticate, associate. A lot of people go looking for them on each of the link frequencies, and they aren't there. And one thing that you will see, not so essential in a beacon, but there will be a station profile that represents each of the link. So for example, in a probe response and an association, the AP may respond with two station profiles, one for 2.4 gigahertz, one for 5 gigahertz. Probe requests, note that probe requests are a different type of multi-link tag. They are not basic. They are a particular probe request type. They don't contain the exact same information. And notice that the client is probing for a link ID that it may have learnt about in an RNR field on a different frequency. So the client says, hey, tell me about this link, please. And in probe responses, we back to standard basic multi-link elements again. You will see the MLD address. And if you dig down into the per station profile under stay info, you will see the station MAC address. And then you'll see the standard probe response for that frequency, the standard other elements. An association request, and one other thing as well that you might be surprised at, you may see MLO elements in authentication exchanges. That trips people up. In an association request, you will again see an MLD MAC address and station profiles. And I'm just going to speed up on this now. And you will see each station will have its own stay MAC address. But watch out for this. The stay MAC address can apply to an AP or a client now. Okay? It doesn't say AP MAC address. It says station MAC address for the individual link address on an AP. And then the association response, very much like the beacon. And I think I want to bring this to an end now. I will just mention that NC Expert now does ubiquity training. We do have some classes coming up. I think we have a special promotion on at the moment as well. If anyone's interested in booking some future classes. And we, of course, do consultancy as well. If you have a Wi-Fi problem, ask us to help and we will, of course, help you out. Final show of the contacts. That is the end of the webinar.
You did a great job there, Phil. Thank you very much.
Thank you, Reed.
For that. And I think we all enjoyed that. So that's great. Well, thank you very much. And thank you, everybody, for visiting with us and attending this. And then next month, what did you say the goal was for certificates?
Yes, so certificates, pause, help. We're talking to Tor, who's our certificate security expert at NC Expert, and he's looking to do a talk on certificates and help you survive them. Might be a good way of putting it.
Awesome. Well, thank you very much. Appreciate it. And I think that's it. So we'll draw this to a close. Again, thank you, everyone. And we will see you next month.
Hey, guys.
Thanks.
Good
Take
one.
care. Thank you. Bye-bye.
Okay, bye bye.